Hello, everyone. My name is Josh Mueller, and this is my presentation on Secure Socket Shell Protocol, or SSH, and some hardening recommendations regarding SSH. So, first and foremost, just some general information regarding SSH it's called Secure Socket Shell, or also just Secure Shell. This was developed in 1995 by Tattoo, and I'm not going to try to pronounce that last name. Um, and that's actually a really interesting year that is developed. I'm going to talk about in a second. But in short, SSH encrypts traffic from a client computer to a server or another client, usually over an unprotected network. Telnet and rlogin were used before SSH and were not as anywhere near as secure as SSH. SSH uses strong authentication between the two devices using what are called keys, which we're going to get into here in a second. And then SSH utilizes TCP, the TCP/IP protocol on port 22. And one thing just to note regarding this presentation is that there's a lot of information surrounding SSH, which encompass authentication, encryption, decryption, negotiation between the client and a server or a client and a client. So I chose to focus on a very specific subset of information about SSH to hopefully kind of paint a picture of the overall uses of SSH, which I'm going to get into here in a moment. And another thing to note too regarding SSH is the time that it was developed, right? I mentioned that that Telnet and the rlogin were used before SSH. And if you think of kind of the time frame, 80s, 90s leading up to 2000s, not as many people were surfing the web as we do now, and we weren't as just kind of digitally utilizing what we use now. So it's just an interesting time frame when it was developed, just because of all the upcomings and of kind of our technology stage in life. So SSH really came at a good time for that. All right, so I wanted to focus on some of the encryption techniques used regarding SSH, and then talking about actually how SSH works. So it's important to understand these encryption techniques, just because any kind of SSH session is going to use some, if not all, of these. So SSH can utilize three different kind of encryption techniques. Those involve symmetrical encryption, asymmetrical encryption, and hashing. So just to get right into it, what is symmetric encryption, right? So with all these kind of encryption techniques, you're going to hear the term keys. So kind of what is keys? What does it do? So keys is just a form of a handshake used to connect two entities, again, between a client and a server, or client and a client. So think of keys as kind of like a digital signature between both. Just again, that handshake that is used. It's like, hey, I want to connect with you using SSH. Okay, cool. Let's start from there, right? So talking about symmetric encryption, it's also called shared key or shared secret, which is important to know. So symmetric encryption, given the name symmetric, means that there are similar parts that are the same, right? So looking at my picture here, between this client and a server, I have two keys that are the same, right? So in symmetric encryption, this means that the two keys, again, that are the same, which is important, are used when transferring data across a network. These keys are used for encryption and decryption. And I found this quote, in a lot of these encryption processes, I found quotes that just really articulated really well kind of the overall process of these encryptions. So the process of creating a symmetric key is carried out by a key exchange algorithm. And that algorithm I'm going to talk about a little bit later here. this key is never transmitted between the client and the host. So once the authentication method is determined between, let's just say, this client and the server, that's where the handshake and the communication happens to determine, what keys are going to be used and not used. And again, it's not shared by the client and the host, and of course, any kind of third party as well. And these keys are also used to encrypt the entire communication. And the client and the server derive the secret key, using that kind of agreed upon method when you actually establish a connection. So it's important because these keys aren't just kind of floating around waiting to be used. Once you form that connection, that's when that communication starts. And these keys are established specifically to the connection. So that's symmetric keys, right? So it's just, again, to recap, it's important that you're using this like a pair of the same keys. Those keys are not different. So as you see here, I'm saying hello, it's encrypting it, which again, man in the middle helps with that. And then when it gets to the server, it's being decrypted by the same key that was established between this connection. All right, so moving on to asymmetric encryption. So this is where keys are going to be a little bit different. So asymmetric encryption uses two different keys, so they're not the same keys now, compared to symmetric encryption, which uses the same keys. So symmetric encryption uses private keys, whereas asymmetric will use a combination of public keys and private keys. Now, your private keys are going to be the destination. Your public keys are going to be only for encryption. So public keys can be used by anybody, given the name, but are only limited to the encryption only for, only for sending. Only the private key, again, the destination, can be used to actually decrypt that message. The SSH session that is created between the two parties using the asymmetric session protocol is not encrypted. Only the key exchange algorithm is. So, so in short, right, asymmetric encryption is not used to encrypt the entire SSH session. That's important because symmetrical encryption does. Instead, asymmetrical encryption is used during only the key exchange algorithm of that asymmetric encryption. So before initiating a secure connection, both of the parties, so the client and the server or client and client, generate this temporary public key pairs and share their respective private keys to produce that shared secret key, right? So the green is that public key. The public key is shared with the destination, right? This is why you see the green key. But the red key is that private key. So only the destination party that has that private key can actually decrypt the message. And that's important because if I'm able to decrypt the message in an asymmetric encryption, that means I am authorized to do so. Okay, moving on. So moving on to hashing. So hashing is kind of a one-way street here. So hashing is used for one direction or kind of one way, and the traffic is never decrypted. So as you can kind of see here, I'm encrypting a message saying, "How are you?" During the process or en route, it is encrypted and hashed, as you see here. And then when it gets there, it is still hashed. It is still encrypted. So again, just another quote that articulates this really well is that they generate a unique value of a fixed length for each input that shows no clear trend which can be exploited. So it's, in short, very secure during the en route process. And this makes them practically impossible to reverse. And during hashing, SSH utilizes something called HMAC, which is hash-based message authentication codes. This simply means that any message that reaches its destination will be secured and not tampered with. So a very good kind of a protocol and secure process that it uses. And then hashing is unique because its main goal is to protect the data while it is in storage. So while it is at the server, it is protected. whereas encryption protects the data while en route. So symmetric and asymmetric, the protection comes from while that message is en route, and this hashing is used to protect the data while it's in storage. And admin users can run certain protocols again to check the data as it is in storage, or when it reaches its destination. So now that we kind of understand the three encryption protocols used during an SSH session, we can then kind of put it together and understand how SSH actually works. And how SSH actually works is really quite simple once you understand the backend stuff. So how does it actually work? So SSH, first and foremost, uses three distinct layers to safely connect, right? We use a transport layer, which is responsible for safe encryption and decryption. It uses an authentication layer, which supports the kind of that handshake, right? The agreed upon authentication method that's going to be used. And it also uses the connection layer, which is in control and oversees the communication between the session. And how you actually do it and put it all together is a client, so myself, I will initiate an SSH connection by this command, SSH, my username at the server and or other hostname that I want to, and the IP address of it. And once that request is sent, that's where the handshake begins and the authentication methods are determined. This is all happening on the back end. But of course, because we just understood all the encryption methods, the keys that are going to be created and used for the session are created using and forgive me here, the Diffie-Hellman key exchange. And all that key exchange is just a protocol that allows your the devices to establish kind of that shared secret over that insecure network. And then the communication between the two use the shared secret to create a unique symmetric key for encrypting and decrypting. So that's where all of our protocols come in. So actually initiating that connection is simple, and how everything works on the back end is exactly what we just talked about. So moving on to hardening recommendations, or my 3 hardening recommendations. So first and foremost, number one is changing the default port for SSH. So as I said earlier, SSH by default uses port 22. So this is a very simple hardening recommendation in my eyes, but really effective. Since most people out there use port 22, attackers will use this to their advantage. They're going to find anything that they can't use, but this is going to be used for their advantage. So changing the port number would be categorized under what I found was security through obscurity, which simply means that the security isn't technically enhanced, but the SSH port has been obscured and it isn't as easy for attackers to access. So this means that kind of all those bots listening out there are scanning for SSH connections on port 22. But just changing the port alone is giving you such an advantage in security by not having those bots just listen to it. Because attackers are trying to get into your system the quickest and easiest way that they can. So changing the ports specifically is going to enhance that greatly. So how do you change the port? Very simple. We're going to open that configuration file, which I have listed here. You're going to uncomment the line that says port 22, and you're going to switch to the 2 line and just switch it to the port that you want. So for example, I put 2222 here. And then you're just going to save the changes and automatically you're done. It probably takes less than 5 minutes to do that. And now you won't be kind of in the eyesight of bots or other attackers that are just listening for anything open on port 22. Moving on to hardening recommendation number 2 is disabling the password when logging with SSH, which in your mind may be like, what do you mean disabling a password? Passwords are what are the bread and butter to everything, right? So instead of typing a password every time we want to log in, which I'm sure we all love because we forget all the passwords that we have, we instead will use public keys to be authenticated. And this is way more secure than using passwords. So to do this, we need to generate what's called RSA keys. And I'm not going to try to pronounce that, but I have what RSA stands for. We're going to generate those RSA keys on a single system and then copy the RSA key to the remote host that we're trying to connect to. So let's just say a server. So to generate the RS keys on a system that you're connecting from, because that's important, you're going to type in SSH keygen. You're going to copy the key to the remote system that I'm connecting to. So with this command, you're copying ID from user at the host name. And then once it's copied, you can connect without the password using this command that I have here. And just remember, if you are using RSA keys and they are changed or deleted, you're gonna have to create new keys. So again, very simple, but very effective. My last hardening recommendation is only allowing certain users to be granted access to the server. So this is very specific to a client trying to connect to a server, not a client and a client. So as you all probably know, this is important for many reasons, but too many hands in the pot can start a problem. So allowing only certain users to connect will greatly, one, be easier to organize and manage, but two, you won't have to worry about the risk of other people connecting to the server, let's say over an unsecured network, or certain individuals that you may not want to connect with. So controlling the access will just go a long way. So to do this, I'm using an example. Say my user is KSU student. So you're going to edit, once again, the config file. And then you're just going to allow the user or users that you want, which is just allow users and then whoever that user is. So KSU student. So that is my presentation. These are my references, of course. Again, there's so much to SSH that I wanted to focus on just the encryption methods and how to establish a connection and some hardening recommendations. You can get really in the weeds with SSH regarding authentication methods, like I said, and any other protocols assigned to it. So very open to feedback. Let me know what you wrote about, and thank you for listening.